Okay, so this is the last set of problems on 6.1's homework. We had a lot of questions about how to do these. For these, you're not going to have a calculator. These pertain to the 45-45-90 triangle and the 30-60-90 triangle. So you need to reference these two triangles. That's why you needed to memorize them. So number 21 is asking sine theta equals 1/2. So we're finding theta, so we're finding the angle. So we need to find, sine is opposite over hypotenuse. So this is your opposite, this is your hypotenuse. When is opposite over hypotenuse 1/2? So you know if your hypotenuse is 2, you're automatically in the 30-60-90 triangle, because your hypotenuse is 2. So when is your opposite side 1? When you have a 30 degree. So that means that theta equals 30. So the next one is tangent theta equals 1. So tangent is opposite over adjacent. So when are your opposite and adjacent both 1 in a 45 degree? So theta equals 45. Now we're looking at cosecant of theta is square root of 2. So we have a square root of 2 in the 45-45-90 triangle. So your theta is 45 again. Now you're looking at...
Wait, why is it 45?
Why is it 45? Because your root 2 is in your 45-45-90 triangle.
It's not, you wouldn't put 90?
No. You're never going to be taking the sine, cosine, tangent of the 90 degree. It's the other angles that you're interested in. So 24 is cotangent of theta equals square root of 3. So you know you're in your 30-60-90 triangle. Cotangent is adjacent over opposite. It's the reciprocal of tangent. So if you have your adjacent over your opposite, you're in the 30. So it's theta equals 30. And then we have for 25, that cosine of theta is 1/2. So cosine is adjacent over hypotenuse. So again, we're in our 30-60-90. Our adjacent is 1, and our hypotenuse is 2. So it's 60. And 26 is secant theta equals 2. So secant of theta is the reciprocal of cosine. So we have hypotenuse over adjacent. So our hypotenuse is 2, so we're in our 30-60-90 again. Hypotenuse over adjacent is the 60. So that's what those questions were asking. You have to know those two triangles. So now going to our notes for today. So now we're going to use our knowledge of triangles and the Pythagorean theorem to solve triangles. So we're applying all of our geometry knowledge to solve these triangles. So example 1 is asking you to solve for side x, which is down here on the bottom. So we're given a 65-degree angle here. So can we find this last angle here?
on your meeting.
So if we have a 90 and a 65, to find this other angle, we're gonna take 90 minus 65, which is gonna equal 25. So our last angle here is 25 degrees. And then to find x, we're gonna use one of our trig ratios, whichever one you wanna use. You can use either the 65-degree angle, the 25-degree angle, and whichever trig function you wanna use to find the x. If we're using the 65-degree angle that we're already given, we can use cosine of 65 will equal x over 8. And then getting x alone, we're going to multiply it by 8. And then this you'll just plug into your calculator. And you end up getting that x equals 3.38. Now if we wanted to solve for this longer side, it's not asking us to, but we can. We can name it y. And again, you can use whatever trig ratio you want. So again, using the 65-degree angle, we can do sine 65 equals y over 8. And then again, solving for y. And plugging that into your calculator, you get y equals 7.25. So now, for the next one, and for example 1, you would be able to use a calculator on it. And example 2, now they want us to find angle theta. So this angle right here. So now you can use whichever trig function. You have all three sides given to you. So you can use whichever trig function you want to use. If we have sine of theta, then we would have 3 over 5. We could also do cosine of theta, which would be 4 over 5. Or you could do tangent of theta, which would be 3 over 4. All of these will give you the same answer. Now to solve for this, you're solving for theta. So you're going to go to your trig functions and you're going to do the inverse sine or the inverse cosine or the inverse tangent. And then you're going to put in your ratio that you had, so 3 divided by 5, and you get your angle is 16.87, or 36, sorry. So it equals 36.87. And like I said, all of these ratios will give you the same answer. For example 3, they want you to solve the right triangle that's in the figure there. So you need to find this missing angle and both of these sides. So the easiest part to find to start out with would probably be the missing angle, because you're already given 75 and 90. So to find theta, you would have 90 minus 75. and that'll give you 15 degrees. So our theta here is 15 degrees. And then you need to find both of these sides. So again, you can use the 75-degree angle or the 15-degree angle and use the trig functions or the trig ratios to find those two sides. So to find A, we could use sine of 75 equals A over 17. And then just like we did in the previous examples, you're going to have sine, 17 times sine 75 equals A. Solving for A, you get 16.42. And then similarly for B, we're going to do sine of 15 equals B over 17. So you're going to have 17 sine 15 equals B. And solving for B, you get 4.40. Now, for example 4. Example 4, you're given two of the sides, and you're asked to find the two angles and the third side. So, to find, for this one, I would find the third side first.
Right, because the hypotenuse is double the smallest side.
So Nick just said that the hypotenuse here is double this smaller side. So that automatically tells him that it's a 30, 60, 90 triangle. And we can verify that by finding this third side. So we'll find this side first, and then we'll make sure that this is a 30, 60, 90 triangle. So to find this third side, we're going to use the Pythagorean theorem. So we have a squared plus the 6 squared equals 12 squared. So you get a squared plus 36 equals 144. So you get a squared equals 108. You're going to square root both sides, so you get the square root of 108. 108 can be factored as 36 and 3. So you end up with a equal to 6 square root of 3. Now does that verify that this is a 30, 60, 90 triangle?
Yes.
Yes, because our longer side is a multiple, is the same multiple of the square root of 3. So we know that our theta is a 30 degree, and we know that beta is a 60 degree. Now if we asked you a problem like this on your test, you would not be given a calculator, so you need to know your 45, 45, 90 triangle and your 30, 60, 90 triangles. On the next page, this is a recap of what we just went over for finding or solving for right triangles. So if you're given an angle and a side, these are the steps you would follow. If you're given two sides, these are the steps you would follow. So then going down to example 5. Now we're given that sine of angle C equals 3 over 4, and we're given B equals 12, and we're told to find C. So if we have sine of C, so angle C is right here, and we're told that sine of C equals 3/4. So this is your opposite side, this is your hypotenuse. So labeling C, your opposite side is 3, and your hypotenuse is 4. But we're told that B is 12. So using this other triangle, B is 12. So these are similar triangles. So we can set our ratios equal to each other. So we're looking for this C. So it would be 9 because we have that 4 is 3 times to equal 12. So you can set it up as an actual equation so that you would have 3/4 equals C over 12. And then cross multiplying, you would get that 4C equals 36. And C would equal 9. So this is relating similar triangles. Now, no, example 6. Example 6 is going back to your 45, 45, 90, your 30, 60, 90. And we are asked to find H. So in the first one, we're given that one of our legs is 12. And we're looking for our hypotenuse. So what is our hypotenuse? 12 root 2. Because this is just a multiple of 12 on our original triangle. And then the second one, we're given a 30, 60, 90, and we're looking for our hypotenuse. Our hypotenuse is just double the shorter leg, which we're given, so it's 300. Can anyone tell me what the longer leg would be? 150 root 3. And the last one. We're looking for our longer leg. So that's half of our hypotenuse times root 3. So it's 50 root 3. And our shorter leg is just 50. It's half of the hypotenuse. And example 7. Example 7 asks you to find the side that they're asking for. And they don't give you a triangle, so you have to draw your own triangle. So they're giving us that angle A is 60. So we know we're going to have a 30, 60, 90 triangle. So we can call this angle A, would be our 60, and our other angle would be 30. And for this, you have to remember when you're labeling your triangle that the corresponding side is always across from the angle. So this angle A is 60 degrees. So side A is directly across from angle A. So it would be your opposite side. So this would be A. And then you can label the other two however you want. This could be angle B, this could be angle B, just as long as you do the corresponding sides. So we can call our hypotenuse B and our short side C. Just as long as you keep it consistent. So now we need to find side A. And we're told that side C equals 5. So we have a 30, 60, 90 triangle, so side A would be would be 5 root 3, because it's just a multiple of the original triangle. What would our hypotenuse be? It would be 10. So 18 and 20 are asking us to do the same thing, except now we don't have the nice 30, 60, 90 triangle or the 45, 45, 90. So again, you're going to want to draw your triangle. And you're going to label one of your angles as 37. So now, if this is angle C, this is side C, and that equals 12, which is given. And then we can call this B and this A. And now we need to solve for our third angle, and we need to solve for A and for B. So our third angle is 90 minus 37, which gives us 53. And then to find A and B, again, this is like what we did in the beginning. You can use whatever trig function you want, as or trig ratio you want. So we could do tangent of 37 equals 12 over A. And then solving for A, we're going to have A equals 12 over tangent of 37. And you plug that into your calculator, and you'll get that A equals 15.92. And then we need to solve for B. So we can take sine of 37 equals 12 over B. Solving for B. You get that B equals 12 divided by sine of 37. And you get that B equals 19.93. Problem 20 is the same thing. So you're going to want to draw the triangle. And you're given a 40-degree angle. So that's angle A. So this is side A. And then again, you can label B and C. So again, we need to find our third angle. So we have 90 minus 40. So we get a 50-degree angle. And then we need to find A, B, and C. Oh, we're given A. So A is 8. So we only need to find B and C. So to find B, we can use sine of 40 equals 8 over B. And then solving for B, you get that B equals 8 divided by sine 40. And you get that that equals 12.4. And then finally solving for C. you can take tangent of 40 equals 8 divided by c. Solving for c, you get that c equals 8 divided by tangent of 40, which equals 9.53. And our last two examples, they ask you to find angle theta. So we are given that angle theta is right here, and we're given two sides. So using those two sides, we're going to find angle theta. So we're given the adjacent side and the hypotenuse, which is cosine. So cosine of theta equals 10 over 12. And again, you're going to use the inverse to solve for theta. So on your calculator, you're going to go trig, inverse cosine, and put in 10 divided by 12, which gives you 33.56. And the last one.
We were doing the inverse.
Yes. So our theta is up here, and we're given two sides. We're given the opposite and the hypotenuse. So that's sine theta equals 144 over 200. Doing the inverse of sine, you find that theta equals 46.1.